Hello guys, welcome back to our YouTube channel. Today we'll be looking at the problems from the Codechef Starters 139. I'm Sahil and let's begin. Let's look at our first problem today, distribute cookies. I'll quickly read the problem statement. Chef is making n cookies for n kids. He wants to give everyone an equal number of cookies. He must give at least one cookie to each kid. He has already m cookies. He can destroy or make one cookie in 1 second. So what the problem statement is basically saying is we are given first of all two things, n and m. Here n is the number of kids, n is the number of kids, and m is the number of cookies chef currently has. N is the number of kids and m is the number of cookies chef currently has. And now he wants to give each kid at least one cookie and he wants them to be distributed evenly. So let us understand these two conditions with the help of these given examples. So I have 5 here. First example, I have 5 kids and 17 cookies. So one thing is clear that each kid will receive at least one cookie. That condition is taken care of. Now the second condition is how to distribute the cookies evenly among these 5 kids. 5 kids. So how can we do that? So suppose if each kid gets 3 cookies. If each kid gets 3 cookies, then there will be total. We need 15 cookies. Then we'll need total 15 cookies, right? How much do we currently have? 17 cookies. How much do we have currently? 17 cookies. And if we want to give each kid 4 cookies, we need 20 cookies. We need 20 cookies. So these are the two choices we currently have. We can give each kid 3 cookies, so there will be total 15 cookies we require, or we can give each kid 4 cookies, then there will be 20 cookies that we require. Let us suppose we go with the first case. We go with the first case that we give each kid 3 cookies. Right, so we need 15. We have currently 17. That means we have 2 left. We have 2 cookies left, and what do we need to do is we need to destroy these 2 cookies. We need to destroy these two cookies, and destroying one cookie will take 1 second as mentioned in the problem statement. Yes, destroying each cookie will take 1 second. And so the time taken for this case would be 2 seconds because we need to destroy 2 cookies, right? So the overall time taken for the first case would be 2 seconds because we need to destroy 2 cookies. Now let us look at the second case where we give each kid 4 cookies. So we will require 20 cookies, but we currently have 17 cookies. So we need to make 3 more cookies. We need to make 3 more cookies, and making a cookie will also utilize the same 1 second of time. So we can make 1 cookie in 1 second. So for 3 cookies we require 3 seconds. For 3 cookies we require 3 seconds. Now among all such scenarios we need to choose the minimum time that chef can evenly distribute all his cookies. And among this, which is the minimum? Of course 2 is the minimum, right? 2 is the minimum one. So the output is 2. I hope everyone has understood the problem statement. Let us now proceed to the solution and see how we can solve this problem. So let's see how we can solve this problem. Now first thing we need to check here is if we can distribute the given number of cookies evenly between the given number of kids. So suppose the given number of cookies are 15 and the given number of kids are 5. Can we distribute them evenly? Yes, right. We don't need to add or destroy any more cookies. We can just distribute them evenly. How can we check this? Simply, if the number is divisible by the number of cookies are divisible by the number of kids, that is, if their mod is equals to 0, their modulus is equals to 0, that means the number is even divisible and we can distribute the cookies evenly. We don't need to add or destroy anything. But what if the other case where we cannot distribute evenly? Let us look at the second case itself. So number of cookies are 18 and number of kids are 5. So here when we do the modulus, we'll get the answer as 3. Right. So what is this 3? This 3 tells us the 3 extra cookies are being used. There are 3 extra cookies. So what do we do with this information? Do we destroy these 3 cookies? Or we can add 2 more cookies here and make this 20, and now the mod will be equals to 0. Right. So this is the thing here. We need to check for these 2 conditions. Whatever the modulus value we get, we need to choose the minimum between this value and this 2 value. And how will we get this 2 value? How will we know how many cookies I should add so that I am getting modulus 0? Simply n minus modulus 5. Right. So n is 5 here. 5 minus the modulus is 3. That means I can either add 2 more cookies. I can either add 2 more cookies to make the number of cookies to 20, so that modulus is 0, or I can remove these 3 cookies and make this number of cookies to 15, and so that modulus is 0 again. So among these 2 I need to choose the minimum. Here the minimum is 2, so I will choose 2 again. So this is the logic, but this is not the only condition, but this is not the entire logic. So there might be a case. Let us look at the 4th example itself. Let's take 3rd example. So we have number of kids as 4 and number of cookies as 1. So if we do the modulus, that is 1 mod 4, will get the answer as 1. So that does this mean that we need to add 1 more cookie here? We need to destroy this cookie here? Then can we distribute these cookies evenly? No, right? The number of cookies itself are less than number of kids. So we cannot destroy the 1 cookie we have. Then we will have no cookie left and we will not be able to distribute. So in this case, what we can do is we can only add. There is no other option for us but to add. Right, so I'll just check this condition separately, and if this is not true, then I'll proceed with these 2 conditions. So that was the gist of the logic. Let's proceed to code the problem. First, let us look at the input format. We are given n number of kids and then m number of cookies. Next, I will initialize my answer variable. Now, the first thing I will do is I will check if we cannot distribute each kid at least 1 cookie. When will that happen? If number of kids are greater than number of cookies. In that case, the answer will be simply n minus 7. So as you have seen in here, Number of cookies is 1. Number of kids are 4, so we cannot distribute each one cookie to all 4 kids. So we need to add 3 more cookies, which we will get by just doing 4 minus 1. Else, what do we need to do? Else we need to choose. We need to find the minimum time. Now, how will we find that? We'll choose between number of cookies we can destroy. That will be m mod n, and the number of cookies we can add so that we can even distribute them among the kids. That we will get by doing n minus m mod n. Among these two, we'll choose the minimum one and we'll simply print the answer. So we're matching the sample output. Let's see if this will pass all the test cases. Yeah, it's accepted. In the next question, we have maximum distance permutation. Now let's read the problem statement. Define the distance between two permutations A and B, each of length n as the minimum value of ai minus bi. Find the of permutations of n length n which is have the maximum possible distance. Another problem statement could be a little confusing when you first read it, but if you understand it, it's quite pretty simple. So in the input we are given n, which is an integer value. Suppose n equals to 5 here. We have to first create a permutation of 5. Now what is a permutation of 5? So this I can say is a permutation of 5, which is nothing but all the numbers should be in range between 1 to 5. Their combination doesn't matter. So this is also a permutation of 5. Now this is not a permutation of 5 because we don't have all the numbers from 1 to n. This as well is not considered a permutation of 5. So now that I hope everyone is clear with what is a permutation of 5. Now we have to create 2 permutations of this given n. We have to create 2 permutations and we have to find the maximum possible distance between these 2 permutations. First of all, how do we find a distance between these 2 permutations? So for that, what I'm going to do is I'm simply going to subtract the values from the first permutation with the second permutation. So 1 minus 5, and I'm taking the absolute value here. So this will be 4, this will be 1, this will be 1, this will be 3, and this will be 3 as well. Now how do you find the distance? What is the minimum value here? Minimum value among all these 1, right? So 1 is considered as the distance between these 2 permutations. 1 is considered as the distance between these 2 permutations, and among all such permutations we have to find what could be the maximum possible distance. We have to find what could be the maximum possible distance. So let us keep 1 aside and let's see if we could find any other permutation which will give us a greater answer. So what if I try out this permutation? Let us find the distance now. So this will be 2, this will be 2, this will be 2, this will be 3, and this will be 3. What is the minimum value? 2, right? So now the distance can be considered as 2. Such that you have to find two permutations of A and B such that you get the maximum possible distance. So this is the problem statement. I hope everyone is clear with the problem statement. Now let us see how we could solve this problem. Yeah, so what could be the logic to solve this problem? Now let us look at the sample inputs here. For 3, For 3, this is the permutation which is given 1, 2, 3, 3, 1, 2. The difference here is 2, 1, 1. So the maximum possible distance we are getting here is 1. So we have to output these two permutations. In the output, we have to print these two permutations. Looks like we don't have any other permutation which give us the maximum distance other than 1. So how should we proceed with this problem? So one thing is clear, right? We want to maximize the minimum value that we get when we subtract these two permutations. Right? We want to maximize the minimum value we can get. How can we do that? How can we maximize the minimum value we can get? We have to subtract the minimum value from a larger value, right? That is one thing that we have to keep track of so that we can get the difference as large as possible. Now if you observe here, the first permutation I don't need to change anything. But 3, this can be just my permutations 1, 2, 3. Now what for the second permutation I need to figure out with what values I should subtract so that I can get the answer as max as possible. With what values I can subtract so that I can get the answers as max as possible. So what could be the logic here? Now of course if I just do this 1, 2, 3, this answer will be 0, 0, 0, then 0 will be the minimum distance. So this is not it. What if we do reverse 3, 2, 1? Here we'll get 2 fine, but here we'll get 0 and here we'll get 2. So even though we are getting 2 here, the minimum distance, the distance here is still 0. So this is also not it. What if I divide the array? That is, I start from the middle, I subtract the minimum value which I have. 1, 2 and now 3. What is the permutation? Now we are getting 2, 1 and 1, right? And this is what the answer is. Now let us understand the bigger example. Let's take here 5. So 1, 2, 3, 4, 5. So this will be my first permutation. My first permutation does not change. This will be my first permutation. Now for the second permutation I have to figure out with what values I can subtract. Right. So I'm starting from the middle, and with what value should I subtract here? I'm subtracting from 1. See, I can't subtract 1 with 1, right? And that will give me 0. And if I subtract 1 with 5, even though that will give me 4, but that 1, even this will give me 4, but I could have subtracted this with 2, then this would have given me 3. So I am getting larger answer even though I am subtracting with 2. So I don't need to subtract it with 1, right? Because this is already a max number. I don't need to subtract it with minimum number. See, the distance is the minimum number, the minimum value you get by subtracting all these values. So by just getting one number as max as possible won't decrease your distance. You have to consider among all the values you are getting what should be the minimum distance. So you need to maximize each number as possible, and for that reason I'm subtracting 1 from 3, and then I will do 2 from 4, and then I will do 3 from 5. What is the distance I'm getting now? 2, 2 and 2. How should I subtract these values? If I go here 5 and 4, this will give me 4 and 2. But if I go here 5 and 4, this will give me 3 and 3. So among these, which should I choose? Of course, this is the better one, right? This is the better one here. Because the average, we are considering both the cases, we are getting greater value when compared to this value. So this is simply my pattern. This will be simply my pattern. First permutation will be as it is, and second permutation I will follow this pattern. So if the value of n is 5, n by 5, 5 by 2, which will give me 2 plus 1. So from 3 I'll start my permutation, I'll go till the end, and from 2 I'll start my permutation and I'll go till the end. So this was in case of odd numbers. Let's see for even numbers, will this work out? So 1, 2, 3, 4, 5 and 6. 6 by 2, 3 plus 1, 4. So from 4 I will start. 1, 2, 3, and then from here I will start again. 4, 5 and 6. What's the permutation that I'm getting? 5, 3, 1, 3, 3 and 3. We are getting 1 here, but we don't have to do this, right? We are following our second logic. So I will start my permutation in this way, that is from 3 I'll go in reverse. So I'll go 6 here, then I'll go 5 here, then I'll go 4 here. Now what is the permutation that we are getting? 3, 3, 3, 3, 3 and 3. So 3 is the maximum possible distance that we are getting for these two permutations. So this will be our simple logic. I hope everyone is clear with the logic. Now let us proceed with the code. So in the input format we are given t, and then we are given n, the number of the length of the permutation. So as I have said, the first permutation will be simply from 1 to n, right? So I can just simply print those values. For the next permutation. So what was the index that we were starting with? For 1, 2 and 3 we were starting with 2. That is nothing but 3 by 2 plus 1. So the index term that I was starting my next permutation with. And I'll use an array to store the permutation, and I'll use 1 based indexing, so the size of the array will be n plus 1. From this index I will simply start filling up the values. So a of I will be simply, and also initialize another variable to fill these values. So int v will be 1, and I'm just filling up these values here. Yeah, so our logic was for n equals to 5, what did we do? We were first finding the index. So I was filling up the values from this index, which was nothing but 5 by 2 plus 1. 2 plus 1 equals to 3. So from these values I'm just filling up in this way, 1, 2 and 3. So this is exactly what I'm doing here. filling up these values. And next, from the other index, this I want to fill the values from the reverse, so I will initialize v with n, and here a of I will be b, and then minus minus. Then I'll simply print this array. Let's see if this will work. Yeah, it's passing all the results. So let's start with the next question, sum of n. Now this is quite an interesting question. Let us first try to understand it. Define f of x as the largest divisor of x other than x. For example, f of 12. So we are given a function, so f of n equals to k. Now what this function defines for us is the k is the largest divisor of n excluding n. So for f of 12, 6 is the largest divisor of 12 other than 12 itself, right? So they are given this function, and next what do we have to do? Given integer k, find the sum of all n such that f of n equals to k. Now we are given this k value in the question. We are given this k value in the question. What we have to do here is find all the numbers whose largest divisor is k, add them up and return the answer. So sum of all the numbers n whose largest divisor is k. So basically this is the question. Let's see how we can solve this. So first of all, how do we find the largest divisor? So n by k is something. Let us consider this as y. So here in this case, here n is the number, k is the largest divisor, and when we are dividing this, we are getting some answer as y. So basically n equals to k into y. N equals to k into y. Now we are given this k into the question, and we have to find all the numbers whose largest divisor is k and add them up. Now how do we get this data? For any number n, how do we get the largest divisor? What do you have to do? First of all, let's take any number, let's say 12 itself, and I'm finding the prime factors of 12. So 2 into 2 into 3. These are the prime factors of 12, right? Now I want to segregate this into two parts, k into y. Here k should be the largest possible divisor. If k is the largest possible divisor, then y should be as small of a number as possible, right? So in this case, we have the minimum number is 2. So I can segregate this like this: 6 into 2, 6 into 2. What is 2 here? 2 is the minimum, that is the smallest prime factor of 12. 2 is the smallest prime factor of 12. So in this case, k is 6, smallest prime factor is, that is SPF is 2, this is k and this is n. Let's take any other number. Let's take 15. These are the prime factors of 15. And this is already in this form, right? So this is k and this is the SPF. So k is already given to us in the question. Now we need to find the SPF. How do we find the smallest prime factor? How do you find any number and how do you find the smallest prime factor? Basically, we just have to check, right? So among 2, 3, 5, 7, I'll check with each individual number if is it a smallest prime factor. If it is a smallest prime factor, but of which number should I check? N or k? Should I check with n or should I check with k here? Now it is given that k is in the range 0 to 2 to 10 power 6, 2 to 10 power 6, and n value will of course be greater than k in most cases. Now in which range should we search? Can I say that if 3 is the smallest prime factor of n, it will also be the smallest prime factor of k as well? Yes, can we say that? If you look at this example, what are we doing? We are forming k by singling out the minimum element and then multiplying the remaining elements, right? So yes, k will, the smallest prime factor will also be the smallest prime factor of k. It can be even equals to k. It can be even, yes. So for every number, what am I doing here? Let us take example 3 itself. 3, right? Now for this 3 is, this is k. And this is 5. So I have to basically find the values of y and add them up. And how will I get the values of y? I will simply search in this range to among all the prime numbers that are available. I will check the 2 first. 2 is less than k. Yes, so I will take this. Number is 6. Next we have k is fixed, right? Always. This is 3. This is 9. Next I have 5. This is 15. Now should I take 5 here? I can't take 5, right? Here I can't take 5 because that would be then greater than k. Then k would not, in that case 5 would be the greatest common factor, not k. So I only have to go up until here. That is the till this step, and I just have to add these values 15. So this is what I'll do. Now how to get this value? I'll use here sieve of Eratosthenes algorithm to get these values optimally, and I'll just use that for every iteration. Now let's proceed with the code and see how the code will look like. So in the given input, we are given a single digit t and k in the next line. So I've already written the sieve of Eratosthenes algorithm here. You guys can take a look. I'll just compute those values once and I'll use that for every iteration. Now, after that, what am I doing? I want to find the smallest prime factor, right, for a k. So let me initialize that value with 0. Now, how will I get the smallest prime factor for k? Now, if my k is a prime number, then it itself will be its smallest prime factor, right? 13 is the smallest prime factor of 13. So only if my k is not prime, in that case, what will I do? I will iterate over my sieve of array. I will iterate over the use the prime numbers which are filled using sieve of array, right? And I'll divide each one of them, and the one that divides the first will be my smallest prime factor. That's the simple logic that I'm using. So I've added all my prime numbers in my PR array list. Now till where should I search? I'm searching for the smallest prime factor, right? So I search from till less than, my number is less than or equals to square root of k. Now if my val divides k, then SPF equals to val itself, and I'll break. Else, what I will just update my val. Else, I'll just update my val here. Next, number is a prime, then SPF could be k itself. So here is how I am finding the smallest prime factor. Next, what do I have to do? First, I will initialize some variable which will hold the sum, and next I will do the same thing. Now, while my value is less than or equals to SPF, right, the smallest prime factor, while this is true, what do I do? I will simply add the value of val into k. Here I have to typecast it to long. These values are also typecasted. Now, next, update my val to. Now here also write some validation condition. So if I plus 1 is equals to PR dot size, I'll break. And same condition here as well. If break, let's see if this will work. Okay, we have not printed the output. Four 1536. Let's try to submit this. It's taking out of time. Yes, it's getting accepted. This is it, guys. Hope this video was beneficial for you. If so, please like and share this video. And for more such content, subscribe to Smart Reviews channel. Till then, meet you next one. Bye bye.